Hey guys, your favorite uncle is back, and this morning we are going to be looking at the 2016 February March exam paper. And of course, I know that we no longer write exams in February March, but these papers are very, very interesting. So please, if you haven't subscribed, make sure that you do the right thing, all right? And let's get into the first question. All right, so let's start with question 1. So we're saying solve for x. So we're going to say, right, 1.1.1 x squared minus x minus 12, and this is equal to 0. And when we open our brackets, we're going to say, well, this is x and x. Now the factors of 12, such that when I subtract them, will give me 1. What are those factors? You guessed it. That's 4 times 3, right? And so we know that the bigger product must give us the sign of the middle term. So that means that minus 4x will be bigger. So it takes on the sign of that middle term. So x is equal to 4, or x is equal to negative 3, right? So let's go to the very next one. So they say we've got x into x minus x plus 3 minus 1, which is equal to 0. Now, the moment they say to us we must leave the answer in simplified set form, it means we will not be able to factorize, right? So that's x into x plus 3 minus 1. This is equal to 0. So first, let's multiply out so that we make sure that we put this in standard quadratic form. So that's x times x, that's x squared, x times 3. This will be plus 3x, that's minus 1. This is equal to x. Now, that means the value of a, coefficient of x squared, is 1. Value of b is 3. And the value of c, this is negative 1. Right, so we're going to say x is minus b plus minus the square root of b squared minus 4ac divided by 2a. Right, now let's go and substitute there. That's minus positive 3 plus minus the square root of. If we take this, this is going to be 3 squared minus 4 times our a value is 1, and that's negative 1. That's our c value, divided by, this is 2 times 1. So to simplify this further, this would be plus 3, right? That's minus. Now, if we take that under the square root, that's going to be 9 plus 4. Negative times a negative will be a positive. So that's 9 plus 4, which will give us 13. So this is plus minus the square root of 13 divided by 2. Now remember what they said to us. They said leave your answer in simplified set form. So this would be the simplest way in which we can put it in set form. If you did want to, separate them, that's divided by 2, or x is negative 3 minus root of 3 divided by 2, and that is your final answer. All right, now let's go on to the next question. So they say we've got x into 4 minus x is less than 0. All right, so that's x into 3 minus x is less than 0. Now, I want you to remember, ladies and gents, now if I were to try and multiply these out, now remember, that's 4 minus x, not 3 minus x, that's 4 minus x. So that will be 4x minus x squared less than 0. So if you put it in standard form, you would have minus x squared plus 4x less than x. Now notice in this case, let's try and make everything positive. Well, not everything, but the coefficient of our x squared to be positive. So this will be x squared minus 4x. This will be greater than. Now remember, once you multiply by negative, the inequality changes sign, right? So what do you have? You've got x into x minus 4 is greater than 0. So I wanted you guys to see that part, right? So what are my critical values? So my critical values would be at 0, x is equal to 0, right? X is 0 and x is 4. So I'll have 0 and 4 over there. And please remember this is a parabola, right? But a smiling one. So I know it would look something like this. Okay, I've gotten the coefficient of x squared to be positive. So that would be plus, minus, and a plus. Now, where is this graph greater than 0? You agree with me that it will be greater than 0 here, but it will also be greater than 0 after 4, right? So how will we express this? Okay, so we can say x is an element of negative infinity. Remember, when you say negative infinity, right, we always exclude it, right, all the way up until 4. But remember, we do not exclude 0 in this case. So to 0, not excluded, because they said greater than only, right? And then where is it also greater than 0? That will be at 4, also excluded, all the way to infinity, excluded. Remember, this value will also be excluded as well, right? Or you can express this as x is less than 0 or x is greater than 4. Right, and that is how the cookie crumbles. Right, so let's go on to the next point. You have to be quick in this section, right? So we've got x is equal to right, so that's a squared minus a minus 2, right? Or plus a rather, plus a minus 2. This is divided by a minus 1. So we're going to say this is divided by a minus 1. Okay, and they said it gives us that entire thing over that side, which is, they say a is, okay, those sets of 8 there. So a is 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8. Okay, right, so now we wanted to get the value of x. Now, what I'm going to do is simplify this and say, well, this is a squared. So if we open up our brackets, that will be a times a. That will be 2 and 1, right? Notice this will be positive and this will be negative, right? So this is divided by a minus 1. And what do you note? This part at the bottom will cancel this one. And so what are we left with? We're left with x is equal to a plus 2. Now, if we add 2 to this entire thing, what happens? So plus 2 there, right? That becomes 10, okay? And that becomes 9. And the whole thing in this case becomes just the same thing. So x will be equal to a plus 2, meaning that a, or rather x, will be 8, 8, 8, 8, 8, 8, 8, 8, 8, 9, 0. Okay. And on to the next one. So they ask us to solve the following equation simultaneously. We've got 1y plus 7 equal to 2x, and x squared minus xy plus 3y squared equal to 15. Right, so let's get on to that. So we've got y, so that's y, I'm trying to write this down, y plus 7 equal to 2x. Okay, so we'll make this into equation 1. And we've got x squared minus xy plus 3y squared equal to 15. And we can make this equation 2. So now, let's now try and simplify one of the equations. And of course, the linear equation is always the one that's easier. And you try and avoid fractions, guys. You try and avoid, complex simplification. So in this case, I can take the 7 to the other side and make y the subject of the formula, right? So y is equal to 2x minus 7, okay? And this can be our equation 3. So what are we going to do now? Substitute equation 3, but remember equation 3 comes from equation 1, so I can't substitute it into the equation where it comes from. So substitute equation 3 into equation 2. Okay, so what do we have there? Let's try and substitute. Everywhere I see y, I'm going to substitute 2x minus 7, right? Plus 3 into 2x minus 7 all squared, and this is equal to 15. All right, now let's try and simplify. So this is going to be x squared minus x times negative x times 2x will be minus 2x squared. Negative x times negative 7, that's positive 7x. Plus, this is 3 into, now remember when you've got a bracket that is squared, right, we are going to square this guy. 2x all squared gives me 4x squared. Now for the middle term, all I simply do is take this times that. 2x times negative 7 will give me negative 14x, right? Times 2, so you multiply it by the 2 that is outside. So that 2, I'm not going to use it as a square, but I'm rather going to use it as a multiplication. So this is minus 14x, right? So in this case, I've got minus 14x. Actually, sorry, that's minus 28x. Okay, and in this case, that gives me plus 49. Okay, put that in brackets, and that's equal to 15. Right, so we've got x squared minus 2x squared. That should give me minus x squared. Okay, plus 7x, right? Plus 3 times 4, which will give me 12x squared, right? And 3 times 28, that should give us 80. So that would be minus, that would be 84, right? Minus 84x. And 3 times 49. Okay, so that should give us, okay, let me not crack my head there. 3 times 49, so that I just save time. That's 147. So that's going to be plus 147. Okay, right, I'm gonna bring the minus 15, or rather the 15 to this side, right, so that I just simplify. So I've got 12x squared minus x squared. That will give me 11x squared. And I've got 7 minus the 84x, okay? And that would give me minus 77x. All right, and I've got the 147 minus the 15. Okay, that will give me plus, that would be 130. Would that be 132? Yeah. Okay, so that would be 132, and this is equal to 0. Now let's see if we can divide every term by 11. Okay, so if I took 132 divided by 11, that does give me a whole number there. So let's divide everything by 11. So this will be x squared. 11 divided by 11 gives us 1. Minus 7x. So this gave us 12. And this is equal to 0. Okay, and we factorize. And we've got x and x. Okay. Factors of 12 such that when I add them, give me 7. It's definitely 4 and 3. And in this case, my signs are negative. That will be the sign of the middle term. Right, so this would be x is equal to 4 or x is equal to 3. Now I want you to please note, ladies and gents, now which means we now need to get the corresponding y values. And all I'm going to do is to take my solutions, right? As long as they are not going to make my equation undefined, so I'm going to substitute back into equation 3. So substitute x is equal to 4 in equation 3. So we had y is equals to 2x minus 7. So y would be 2 times 4 minus 7, right? And then y is equal to 2 times 3 as well, minus 7. And this is going to be, all right, 2 times 3 is 6, minus 7, that gives us negative 1. And 2 times 4 is 8, minus 7 would give us positive 1. Okay, so there we have it. Y is plus or minus 1, x is 4 and 3 respectively. And now on to the next one. So they say determine the range of the function y is equal to x plus 1 over x. Right? They say x is not equal to 0, okay? And x is real. Now, in this case, I want you to note, ladies and gents, so when we want the range, remember we are talking about the minimum and the maximum y values, right? So for this equation, now it would be very difficult for us to find the range in its current format, right? So what can we do in this case? Let's try and simplify this as much as we possibly can. So we're going to say, right, we've got y is equal to, okay, let's go back to our original color. So we've got y is equal to x plus 1 over x. And so what that does is that we can multiply throughout by x, right? So meaning everything on the left and on the right hand side, we are going to multiply by x, and what I do on the left, I do on the right. So I'm going to have xy, okay, equal to x squared. So x times x, that's x squared. X times 1 over x gives me 1. Right, so that gives me x squared minus xy plus 1, and this would be equal to 0. Right, all I did was to take the xy to the other side, and I'm left with a 0 on the other side, right? So now I want us to note, ladies and gents, now they have told us that x is a real number, right? So what does that mean? It means delta x for this equation has got real roots, right? So what do we know about real roots in this case? So they said to us, we've got real roots. So that means that if we took, right, we tried to factorize this, there should be x-intercepts. And when are roots real? In this case, when we use the discriminant, roots are real when delta is greater or equal to 0, right? Now let's take our delta value. What is our delta value? That's going to be b squared minus 4ac. That should be greater or equal to 0. So greater or equal to 0. Our b squared value, so b, remember the coefficient of x. So you can look at this as minus yx. So the coefficient is negative y, right? Minus 4 times our coefficient of x squared is 1. And our coefficient, our c value is 1 as well. And this should be greater or equal to 0. Now note, sorry, I forgot the square there. So this should give us y squared minus 4 is greater or equal to 0. Right? So let's try to factorize there. And so this would be y and y. This would be 2 and 2, right? So our critical values are positive 2 and negative 2. Now note, right, if we were to plot this as a quadratic function, right, or as a parabola, right, where would we in this case have positive values? So this would be plus minus plus, so that means negative 2 would be included, right? Anything from negative infinity, anything from 2 all the way to infinity. So where is the graph positive? It's positive where y is an element of negative infinity all the way till negative 2. Now it is included in this case, and where we've got 2 all the way to infinity. And in this case, that's how we would get that value, right? Or you can say to us, y should be less than or equal to negative 2, or y should be greater or equal to 2. And that would be the range of this graph, right? So the range should be negative infinity to negative 2, and from 2 to positive infinity. And that is how the cookie crumbles. And off to the next question we go. And off to question 2 we go. They say, given the following quadratic sequence, we've got negative 2, 0, 3, and 7. They say write down the value for the next term of the sequence. Now, remember, for any quadratic sequence, the first thing that we need to do is to first establish what is the first difference of that sequence and the second difference, right? So let's check. For the first difference of this sequence, I'm going to do this in a different color, right? So for my first difference, I'm going to have, okay, so if I say 0 minus a negative 2, that will give me 2. And I say 3 minus 0, right? So that's 3 minus 2, that will give me 3, right? And if I say 7 minus 3, that's 4 minus 3, that would be 4. So can you see that in this case, it keeps increasing? My second difference, or my first difference rather, keeps increasing by 1. So what would be the next term of the sequence? It means I'll just add 5 to it. And so the next term should be equal to 7 plus 5, which will give me 12. So we know that the next sequence should actually be 12, right? So, but just because we know, what would be our second difference of the sequence? Well, our second difference, which is usually a common difference. So 3 minus 1, that would give us 1. 4 minus 3, that's 1. That's 5 minus 4, that would also give us 1. Right? So in this case, we know that our second difference is 1. Now they say to us, determine the expression of the nth term of the sequence. Now, if we want the nth term, it means we're going to have to find out what the value of A, B, and C are respectively. Now remember, the second difference, this would be equal to 2A. The first difference is 3A plus B. And the first term of the sequence is A plus B plus C. Right, so what are we going to do? We're going to say 2A is equal to 1. So A would be equal to, if we divide that by 2, A will be 1 over 2. And in this case, to get the value of B, we say 3A plus B will be equal to 2. So B will be 2 minus 3 times A. But remember, A is 1 over 2. So this will be 2 minus 3 over 2. And so that will also give us 1 over 2. And finally, we're looking for the C value. We said A plus B plus C should be equal to our term 1. Our term 1 is negative 2. So that's negative 2. So that's 1 over 2 plus 1 over 2 plus c should give us negative 2. And if I say 1 over 2 plus 1 over 2, that gives me 1. And plus c is negative 2. And if I take this to the other side, that will give me negative 3. And so that means that the nth term of this sequence will be half n squared plus 1 over 2n minus 3. And that would be how we get to the nth term of this sequence. Okay, right, so let's go on to the next one. They say which term of this sequence will equal to 322, right? So we want to know what value of n will give us the 322. So 3.1.3. So we know that Tn is equal to 322. So half n squared plus 1 over 2n minus 3 should be equal to 322, right? And let's try and simplify. So half n squared plus half n minus, now if I take this to this side, remember that becomes negative. So I end up with 3, so that's 325, isn't it? 325. And this is equal to 0. Now to try and solve this, let's try and multiply, or rather let's multiply by 2. So multiply the entire thing by 2. What I do on the left, I do on the right. So I end up with n squared plus n minus, this is 650, and this is equal to 0, right? Now, which factors can we use for 650 that will be able to give us, okay, let's see, let's check. So if I say, let's see, what's 650 divided by 50? Okay, so I get 13. Okay, let's see. If I say 13 times 2, that's 26, right? So if I say 650 divided by 13, divided by 26 rather. You see, I get 25. So 25 and 26. So definitely that may equal to 1. So in this case, so that would be n26 and n25, right? So one of them has to be negative. So in this case, that guy is positive and this one negative. So n is negative 26 or n is equal to 25. Now, which answer are we going to take, right? Remember that n has to be an element of natural numbers, right? You cannot get a negative number of sequences. So as a result, this is not applicable. So therefore, n is equal to 25. Okay, right. So that would be the value for n. Okay, so now we go to the next question. They say consider the arithmetic sequence that has a second term equal to 8 and a fifth term equal to 10. So ladies and gents, please note, they did tell us that it is an arithmetic sequence. So we know that for an arithmetic sequence, we've got a plus n minus 1 times d, right? So they are telling us that we've got a, initially they said the 8th term, right? Or rather, sorry, the 2nd term, which is equal to 8. So T2 is equal to A plus, now 2 minus 1, that's 1. Okay, so that's 2 minus 1 times D, and they're saying this is equal to 8. But they're also telling us that T5, right, the 5th term is equals to 10. So we know this is A plus 5 minus 1 that would be 4 times d is equal to 10. So I've got two equations. One, a plus d is equal to 8. Let's call that equation 1. And I've got a plus 4d is equal to 10. So what did they want us to find? They wanted us to find out or determine the common difference of the sequence, right? Now, to get the common difference, I can do this in either one of two ways, right? So let's call this equation 2, right? If I said equation 2 minus equation 1, okay, in this case, that would give me a minus a would be 0, 4d minus d would be 3d, right? But otherwise, what you could have done is that from equation 1, just to make things easier for you, right, we can say a is equal to 8 minus d. So everywhere I see a, right, so let's call this equation 3, and let's substitute this into substitute equation 3 into equation 2, right? So my a value, that would be 8 minus d, right, plus 4d. So what did I do? I substituted for a there, a minus d, plus 4d, and this would be equal to 10. All right, let's work this out. So I've got minus d plus 4d, which would be 3d, okay? And I've got 10. If I take the 8 to the other side, it becomes negative. So 10 minus 8 will give me 2. And so divide both sides by 3. And so I know my d value, my common difference, would be 2 over 3. Right, okay. And then they ask me, write down the sum of the first 50 terms of the sequence using sigma notation. Okay, so now let's find the general term of the sequence. So firstly, I need to, okay, so we're at 2.2. Okay, this would be 2.2.2. That was 0.1. Okay, now I'm looking for the general term, so I need to find the a value, right? But remember, I've already found the d value. So a would be 8 minus d, which is 2 over 3. Okay, so our a value will be 8 minus 2 over 3, and that gives us 22 over 3. That's our a value, right? So now the general term of the sequence, Tn, is a 22 over 3 plus n minus 1 times d, right? But what is our d value? That's 2 over 3. So to write this, we get 22 over 3 plus 2 over 3n minus 2 over 3. And so what do we get there? That gives us 2 over 3n, right? Plus 20 over 3. Or if you want to, I can express it as 1 over 3n plus 20. Okay, right, now they said I should write the sum of the first 50 terms, right? So this is going to be from n is equal to 1 all the way to 50, right? And my equation would be 1 over 3 n plus 20, right? And that's how I'd write the sum of the first 50 terms as a sigma notation, right? So next question. Okay, so now they say to us, determine the sum of the first 50 terms of the sequence, right? Now, what I can do, ladies and gents, is that I can just simply use, firstly, I know what my a value is, right? My a value, we said, is 2 over 3. So if I substitute n is equals to 1 there, right? No, not 2 over 3 rather. My first term rather is 22 over 3, right? That's what we got. So that's 22 over 3, right? Now, I can find out what my last term is, right? How do I do that? I just substitute 50 there because that's the 50th term, right? I can say this is 1 over 3, right, into 50 plus 20. And so this would give me 70 over 3, right? Okay, so alternatively, what you could have done is just use that formula there, okay? So that would be 50 minus 1 times 2 over 3, and you add all of that up. So that's our last term. So sum of the first 50 terms, let's write the general formula. This is n over 2 into a plus l, right? And so what do we get? This is sum of the first 50 terms. That's 50 over 2 into 22 over 3 plus 70 over 3. Okay, right, and what do we get there? If I add 50 over 2, okay, the sum of these two gives me, that's 92 over 3. Okay, and as 50, if I say 25 times 93 over 2, and in this case, well, if we want to write it as a fraction, that would be 2325 over 2, right? Or otherwise I can write it in that format there. Right, what was another way in which I could do this? Right, remember Sn, this would be n over 2 into 2a plus n minus 1 times d. So if I'm looking for S50, that would be 50 over 2 into 2 times our a value, that's 2 over 3, plus n minus 1, right? So remember, I have 50 minus 1, which is 49, right? Times, my a value rather was 22 over 3, right? And this is times 2 over 3. All right, so let's see if we get the same answer. So we've got 50 over 2, and this is into, that's 2 times 22 over 3 plus 49 times 2 over 3. Okay, right, so that's, okay, we get, okay, so why do we get a different answer there? 1183, let's see. So we said 50 over 2. Okay, ideally we should get the same answer, ladies and gents. All right, yeah, it could be that I might have done just something, a bit of an error there, but we should get to the same answer. I'm not sure which one is correct between the two. Please let me know if you get to the right answer. All right, so that is how that cookie crumbles, right? And in this case, we leave it there. That's out of 18 marks. All right, and on to the next question. And on to question 3 we go. So they say Chris bought a bonsai, that's a miniature tree, at a nursery. When he bought the tree, its height was 130 millimeters. Thereafter, the height of the tree increased as shown below. Right, so they say during the first year, it was increased by 100 millimeters. And then during the second year, it increased by 70. and on the third year by 49. So they say Chris noted that the sequence of height increase, namely 100 meters, 70 and 49, was a geometric sequence, right? Was geometric rather. So they say during which year will the height of the tree increase by approximately 11.76 millimeters. Now, I want you to note in this case, so firstly they say to us this is a geometric sequence, right? So we know that our A value, that's 100, that's 70, that's 49, right? Now they wanted to know the year wherein that number will be 11.76, okay? And we want to know which year that will be. So what are we going to do? First of all, let's find out what is our A value. We know that's going to be 100. We know what is going to be our R value. Our R value, remember for the geometric sequence, we've got a common ratio, right? So we determine our R value by T2 divided by T1. Okay, so that's 70 over 100. That should give me 7 over 10. But you can also do the same. Check if it's equal to term 3 divided by term 2. So if I say 49 divided by 70, right? So again, okay, so I would still get 0.7, right? And that's approximated, right? Well, not approximated, it is actually 0.7. Okay, right, now let's go on to the question that they've asked. So we want to know what is the n value. So remember, what is the general formula? That's ARN minus 1, right? So we're looking for the n value. So A is 100, R is 0.7, n minus 1. They want to know when will it be equal to 11.76. Now let's do our gymnastics, right? So divide by 100 on both sides. Okay, so that cancels with that. And if you want to make it easier for you to solve, okay, right, what am I going to do here? I can introduce logs, right? Log of 0.7 n minus 1 is equal to the log of 11.76 over 100, okay? Right, now remember, the law of logs simply says if we've got an exponent there, it can jump down. So I've got n minus 1 into the log of 0.7 will be equal to the log of 11.76, and I'm going to keep it that way until I actually divide by that, right? So divide by log of 0.7, divide by log of 0.7. Okay, that cancels with that. I'm left with n minus 1. So let's try and get that answer. So I've got the log of 11.76 over 100, and I divide that by the log of 0.7. Okay, right, I get a value of 6 there, and if I take the 1 to the other side, right, so that becomes a plus 1, so n will be equal to 7. So that means that's on the 7th year. During the 7th year, it will actually grow by 11.76. So therefore, that would be on the 7th year. Okay, right, so going on to the next one, they say Chris plots a graph to represent the height hn of the tree in millimeters, right? that is n years after it was bought, he bought it, right? Determine the formula Hn. Now remember that the initial height of the tree was 130, and thereafter it increases by that, geometric sequence, right? So please don't forget the 130 there. So for 3.2 Tn, okay, so this is ARN minus 1. So let's simplify that. We know this is 100 R. We said our value for R was 0.7, isn't it? So 0.7 n minus 1, right? But now Hn would be 130 plus 100 into 0.7, or you can say 7 over 10, n minus 1. And that is what the equation for Hn would be. Okay, right. So they say, what height will the tree eventually reach? Now please remember, ladies and gents, we can see that our R value is actually what we call a fraction, right? It should be a proper fraction. That's the word I'm looking for. Our R value is less than 1. It is greater than -1. That's a proper fraction, right? So that means that we can get the sum to infinity. So that's what they want us to get, right? So what's the sum to infinity for this tree? That's A over 1 minus R. Our A value, please remember this was 100 divided by 1 minus our R value is 0.7. So sum to infinity, right? So remember, this is a convergent sequence, because if our R value is between -1 and 1, it keeps the value by which it increases keeps getting smaller and smaller, right? So we're going to say this is going to be 100 divided by 1 minus 0.7, okay? And we get 333.33, right? So the tree will grow by this. This is the maximum growth of the tree, right? But what did they want to know? They wanted to know what height will it eventually reach. So remember, so it will be the height of the tree, okay? So the height of the tree will be equal to, right, the initial height 130 plus the sum to infinity. So 333.33, and so that would give me 463.33, and that's in millimeters, right? So that is the height that the tree will eventually reach. And that's it. And on to question 4 we go, right? So they say given f of x is 2 to the exponent minus x plus 1, they say determine the equations of the y-intercept of f. So remember, how do we get the y-intercept? This is where x is equal to 0. So we know this is where x is equal to 0. So f of 0 would be equal to 2 minus 0, right, plus 1. Now remember, anything to the power 0 is 1. So that would be 2 to the exponent minus 0 will give us 1. And 1 plus 1 will give us 2. And that means our y-intercept will be at 0 and 2. So that's the y-intercept. Okay, right, the next question. It says sketch the graph of f, clearly indicate all intercepts with all the x's as well as any asymptotes. Now remember guys, what you normally would have in a normal exponential graph, okay? This is what the graph would look like, okay? But I want you to please remember in this case, what do we have? We've got the x value, right, being a negative, so which means it's a reflection around the y axis, right? Please go and watch my videos on functions, right? So we can actually write it in this way: f of x is equal to 1 over 2 x plus 1, right? So that's 2 minus x, so that's the same as 2 minus 1. So where that comes from is that it was written as 2 minus x, but remember the rules on exponents is that I can write that as 2 minus 1 to the exponent x plus 1. And what is 2 to the exponent minus 1? That's the same as 1 over 2. So that's 1 over 2x plus 1, and that's equal to our f of x value, right? So now I want you to please note, what's our graph going to look like? Okay, so usually the graph of the exponential graph would usually have an asymptote on the line y is equal to x, right? Okay, I mean y is equals to 0, right? Meaning the x-axis, right? But now what did we do? We shifted it 1 unit up, and that's why our y-intercept was at 2 instead of 1 as per usual, right? So our y-intercept is now going to be at x is equal to 2, okay? And that means, in this case, our asymptote is no longer going to be at x is equal to 0, or rather y is equal to 0, right? But it is now going to be on the line y is equal to 1. So that automatically becomes our asymptote, okay? So what do we have for our graph, right? So that would give me, right, so this is what my graph would look like, okay? Right, you can find yourself some more x values if you want to, but essentially that is how the cookie crumbles. So that's your exponential graph. So that's x as well as y. Okay, right, let's go on to the next question. They say calculate the average gradient, right, of f between the points on the graph where x is equals to minus 2 and x is 1. So what would we need to do? Right, so let's find those points. Firstly, that's minus 2 and 1. So f of minus 2, and we're going to have to find f of 1. Right, f of minus 2, ladies and gents. So that would be 2 minus 2 plus 1. 2 minus, oh, in fact, that was minus 2. Sorry about that. So that's negative 2, right? And f of 1. And this is plus 1. So this now, what will it give us? It will give us 2 squared, right? Plus 1. So that's 5. And I've got, in this case, 2 minus 1, that's 1 over 2, plus 1, and that gives me 3 over 2. So they wanted the average gradient between those 2 points, right? And so how are we going to get the average gradient? So the average gradient, okay, my spelling. So the average gradient, okay, this would be equal to f of 1 minus f of negative 2 divided by 1 minus negative 2. Okay, right, so that's going to be y2 minus y1 over x2 minus x1, right? So f of 1, we found that to be equal to 3 over 2 minus f of negative 2, that was 5, divided by, now that would be 1 minus a negative 2, that would be plus 2. Okay, right, and how do we get that answer? So we have 3 over 2 minus 5. Okay, so that should give us 3.5, which is 7 over 2. So that's negative 7 over 2 divided by 3 in that case. So remember that now when we use the law of fractions. So negative 7 over 2, that's divided by 3, so that would be multiplied by 1 over 3. So that gives us minus 7 over 6. And so that would be the average gradient between those 2 points. It would be negative 7 over 6. Right, and then finally, they say if h of x is 3 times f of x, write down the equation of the asymptote of h, right? So meaning, what we are doing now is multiplying everything by 3. So h of x, so I want you to note for our 4.4, so we know that h of x is 3 times f of x, okay? 3 times f of x. So this would be 3 times. Now, please, I want you to note, ladies and gents, so what is our f of x? That's 2 minus x, right, plus 1. So what happens? We've got now that scaling factor, right? So that's going to be 3 times 2 to the minus x. Now, I want you to note what, plus 3 there. This would be a plus 3 over there, right? So that's our h of x. Now remember, what happens at the y-intercept? That's what they wanted to find out, right? The asymptote. So how much did we shift this graph by, right? So we would have shifted this graph, okay, by 3 units in this case upwards, right? So we would have shifted it 3 units. So our asymptote, or the value of our asymptote, now would be at y is equal to 3. Okay, right, and that is how the cookie crumbles for this question, right? And on to question 5 we go, right? So they say to us, we've got a graph of the functions rather, f of x, which is ax plus p all squared plus q, and g of x, which is k over x plus r plus d, right? They are sketched below. Both graphs cut the y-axis at negative 4, right? We can see that quite clearly there. It's marked out. Okay, so there's our y-intercept for both graphs. And they say one of the points of intersection of the graph is negative 1 and 8, okay? Which is P, which is also a turning point of F, okay? And they say the horizontal asymptote of G is y is equal to negative 2. All right, now let's get right into the thick of things. They say calculate the values of A, P, and Q. Now we are dealing with the parabola. Now remember, we already have the x value and the y value of the turning point. So we already know what the P value is, right? So remember, the P value will be the x value of the turning point, but remember to change the sign, so that will be minus 1. And the Q value, that would be negative 8, right? So all we need to do now is to get the value of A. So I'm going to say right. So 5.1, I said the p-value is -1. The q-value is -8. So our equation is f of x is a into x minus 1 squared minus 8, right? So now to get the a value, we need to now substitute another point, right, that we know of into the in the equation. And what point is that? We know the y-intercept where x is 0, y is -4, right? So I'm going to say, right, let's take f of 0. So this is a into 0 minus 1 squared minus 8, but we know this is equal to -4. So this would be a times -1 squared is 1, right? If I take the -8 to the other side, right, what does this become? -4, right, plus 8, and that should become +4, right? Okay, so in this case, what does this now become? So that a is equal to 4. So which means that our equation of the parabola would be 4 into x minus 1 squared minus 8. Okay, right, and that is how the cookie crumbles there. All right, so the next question, they say determine or calculate the values of k, r, and d. Right, so firstly, let's look, right? So we know what is the horizontal asymptote. That's y is equal to -2, right? Now the horizontal asymptote, ladies and gents, would be this value over here, which is d, right? So that would be our d value. So we need to find out now what is the r value, okay? And in this case, what would be our k value, okay? So the x value of the asymptote as well as the k value. Now remember, what do we know? We know that our hyperbola passes through the point P, which is 1 and -8, but we also know that it passes through the point -4, 0 and -4, right? So those are the 2 points that we are going to use, right? So I'm going to say, right, so for 5.2, we've got g of x, right, which is k over x plus r, isn't it? Right, so that's k over x plus r. And now remember the y value of the asymptote, right? We said this is going to be -2 as it was given there, right? So now, what can we substitute? We can substitute the point P, which is 1 and -8, but we also know the y-intercept in this case, which was the point 0 and -4. Right, so let's get the first one. So g of 0, right, that would be equal to k over 0 plus r minus 2, and we know g of 0 is equal to -4, right? So that means k over r minus 2 is equal to -4, okay? So if I take the 2 to the other side, it becomes positive, so which means k over r is equal to -4 plus 2 will give us -2, so k is equal to -2r. I'll make that my equation 1, right? And now let me substitute g of 1, and what is this equal to? That's equal to -8, right? So I'm going to say, right, to my original equation again, so g of 1, this would be k over, remember x is 1 plus r, and this minus 2, and this now is equal to -8, okay? Right, so now we've got another equation. So that's k over 1 plus r, okay, and which is equal to, if I take that to the other side, it becomes positive, and so I've got negative 6, right? So if I cross multiply again, this is over 1, so k would be equal to, now please note in this case, ladies and gents, if I cross multiply, right, this is equal to minus 6 into 1 plus r, and this is equation 2. Now remember, I've got two values for k in this case, right? So k is minus 6 into 1 plus r, but k is equals to negative 2r. So equation 1 is definitely equal to equation 2. So I'm going to take everything that's on the right hand side and equate it. So minus 2r is equal to minus 6 into 1 plus r. Okay, so this is minus 6 minus 6r is minus 2r. If I take the positive and the negative 6r to the other side, that becomes positive. So I've got 6r minus 2r will give us 4r is equal to negative 6. And now what should be my value for r? Divide both sides by 4. And so r would be equal to minus 3 over 2. Okay, so now we're looking for the value of k. So I can substitute the value of r into that equation. So k, so substitute. Okay, so substitute r is equal to minus 3 over 2 into equation 2, right? Equation 1 actually. So k is equal to minus 2 times r, right? But what is our r value? We said this is minus 3 over 2, and so k is equal to a positive value this time, and that's positive 3. Okay, so we've got the value of kr and d rather. Okay, so kr and d, we've got that value. So meaning if I were to write the equation of g of x, right? Remember that was k, that's 3 over x minus, now remember our r value, right, is minus 3 over 2, okay? So that's minus 3 over 2. And in this case, our d value was minus 2. Okay, right, so that would be minus 2 over there. So that's our equation for g of x. Right, as we continue to the next one, now they say determine the values of x in the interval x is less than 1. So meaning we're looking on the left hand side, right, of our turning point of the graph of f, right, for which g of x is greater than f of x. Now remember, where is g of x greater than f of x? Remember, g of x is the, that's the hyperbola, right? So we want essentially where the hyperbola is above the graph of f, right? The parabola. So where is that? Now notice here, g of x is below, right, the parabola. Okay, there's our parabola there. It's always high in this case, right? Up until we get to this value over here, right? What begins to happen? There is my g of x above the hyperbola, above the parabola. So that would be for x is greater than 0, okay? And it must be less than 1 in this case. So it's only between that point 0 and 1. So remember they said greater than or equal to. So I'm going to include both 0 and 1. So 5.3, I'm going to say x is an element of 0. It is equal at 0, and also it is equal at 1. Or you can say x is less than 1, less than or equal to, and greater than or equal to 0. Okay, right, and that is how you are going to express that solution there. Right, quickly, let's go on to 5.4. So they say determine the values of k, right, for which f of x is equal to k has two unequal positive roots. Okay, now I want you to note, ladies and gents, so at the moment, what can we say about the graph of f of x, right? So definitely it has two unequal roots, right? But are those roots positive? Okay, that's what they said. The roots need to be positive. Okay, now let's do this. If I were to rewrite this f of x, so this would be f of x minus k is equal to 0. And what are they saying to me? How much would I need to shift the graph of f of x such that the roots are unequal, okay, and they are positive, right? Now I want you to note, if I were to shift the graph, right, upwards such that this point here sits on the on the origin, right? Now, in order for this point to shift to the origin, what would my graph look like? So it would be something like this, right? So I would have shifted my graph upwards. I know my graph is inaccurate when I draw it like that. Okay, so I would have shifted my graph something like that, right? It can't be my turning point there because I would have shifted the graph upwards. Okay, right. So in this case, do you agree with me that if I can shift it by any value that is greater than this here, right, it would sit at 0 first, but beyond that, it would shift, it would sit at any value that is greater than, that is positive, right? But now remember they said unequal, so I can't have a situation where my graph does this, okay? So I can shift it by 4 units and up, but I can't shift it by anything more than 8 units, okay? Right, so because once I shift it by 8 units, it means that my roots would now be equal, right? So k must be any value. Now, please note in this case, I am shifting it up and already k was negative. Né? So k must be between, right, -4. So I need to shift it up by 4 units upwards. Okay, so I'm going to say k must be an element of. Now note, ladies and gents, in order for it to be upwards, it must be -4, right? But k cannot be greater than, in this case, -8. Actually, I must say k is an element of -8 to -4. Or you can write it as k must be less than or equal to -4, actually not equal to, and greater than -8. Right, I hope that makes sense, ladies and gents. Right, otherwise what you can do is you can use nature of roots, okay, to determine that. Okay, but I won't go through it in this particular case. That's only worth 2 marks. Okay, so I think this was sufficient. Right, now they say to you, write down an equation for the axis of symmetry of G that has a negative gradient. Now, remember, guys, for the hyperbola. So the hyperbola is, one of those graphs that, you must know what you are doing there. So remember the axis of symmetry, right? They said that has a negative gradient. So this is what it would look like, right? So I'm trying to just get it there. Okay, so remember those axes of symmetry would actually pass through the intersection of your asymptotes, right? So your asymptotes intersect at what point? So remember, our R value was 3/2, right? Positive and negative 2. Okay? So I know that it has the equation y is minus x, right? Plus, let's say, k1. And what is k1 in this case? We would get k1 by substituting that point of intersection of the asymptote. So we're going to say the equation is y is minus x plus k1. But in this case, we know that k1 passes through the point 3/2 and minus 2. And remember, where did you get the 3/2? This is this point over here, right? So when x is 3/2, right, y is negative 2. So let's get the value of k1. So that would be minus 2 plus 3/2, which is equal to k1. And so the value of k1 would be negative 1/2. So the equation is minus x minus 1/2. Okay, right, I hope that you understand. And of course, if they wanted the one with the positive gradient, that would just simply be y is equal to x plus k2. And to get the value of k2 would still substitute that point there, 3/2 and negative 2. Right, I hope that makes sense, guys. Right, as we move on to the very next question. They say write down an equation for the axis of, oh no, actually we've just gone through that one. They say the point P is reflected in the line determined in question 5.5 to give the point Q, right? So remember, this is reflected, right? And they say to us, write down the coordinates of Q. Now remember, we are reflecting this point over here with the line y is minus x plus or minus 1/2, which is our point of, or our reflection, right? Or in this case, the axis of symmetry. So usually, ladies and gents, this is how I would have looked at it. If it was the line y is equal to minus x, what would have been the point Q? Now, please remember this, right? My point Q would have been a point such that, now note, because it is minus x, I would swap the points around. So I would have 8 and 1, but remember, I swap around the points, but I not only swap around the points, but I swap around the signs because that's minus x, right? So that's minus, that would be positive 8 and negative 1. However, remember that what I've done is it's not just a shift, or rather it's not just a reflection around the line y is equals to minus x, but also in this case there is a shift in this case in terms of that line. But what is the shift? The shift is by 3/2 units, right? Now note, so that means every single point is going to be shifted 3/2 units. So I'm going to have 8, right? So that will be the point 8 plus 3/2 in terms of x, right? But also minus 2. But the same thing for y. This will be minus 1 plus 3 over 2 minus 2, okay, which is that asymptote value, right? And so what would be our Q value? All right, so this would be what would be 8 minus 2 would be 6 plus 3 over 2. 2 times 6 is 12, so this would be 15 over 2, right? And in this case I've got minus 1 minus 2 gives us negative 3 plus 3 over 2. This would definitely be minus 3 over 2 as well. So the point Q, ladies and gents, would simply be the point, okay? So we would just simply say this is the point 15 over 2, okay? And did we say negative? Yeah, minus 3 over 2, okay? Did you see how we did that, right? So I swap around the points with the sign. If it was with the line y is equals to x, you just swap around the points, not necessarily the sign, okay? And what you do is that you add in the values of your asymptotes in that case, because that's how far it has been shifted. Okay, and essentially, ladies and gents, that is how the cookie crumbles as we move on to the next question. Right, as we hop on to question 6. So they said given f of x is 1 over 4 x squared, where x is less than or equal to 0. So they've restricted this graph. They say to us, determine the equation of f minus 1, all right? So the inverse of f in the form f minus 1 of x, right? So now, first of all, ladies and gents, what do we normally do when we get the inverse, right? So I'm going to write it in the form y is equal to 1 over 4 x squared. So this is the graph of f, right? Now, the inverse of that would be x is equal to 1 over 4 y squared. So let's try and simplify that. Okay, so if I multiply both sides by 4, so that will be 4x is equal to y squared. And if I wanted to take y, that will be equal to plus minus the square root of 4x. Okay, so I'll take the square root there. Okay, so remember, if I take the square root on both sides, I have to say plus or minus there. But remember, we are taken only for when x is less than 0. Okay, so meaning x would be on the the negative side. Okay, so that would be the same here. So that means we would have y is equal to minus, all right, 4x. All right, so I hope that makes sense, because we've taken when x is on the negative side. Here it would be where y is on the negative side. Okay, right, so then they say to us, by the way, we needed to write it as f minus 1x, right? Otherwise we will lose marks. Okay, that's square root of 4x. Okay, so the next question, they say to us on the same set of axes, sketch the graphs of f and the inverse, indicate clearly the intercepts of the with the axes, as well as another point on the graph of each, right? So what would the graph of f look like? All right, and I'm going to choose any random point. So remember, this graph is going to be on the negative side. So it would be a graph that looks like this. Okay, so let me take the point where x is negative 1. Okay, so for the graph of f, when x is negative 1, y is 1 over 4. So let's get that point there. When x is negative 1, y is 1 over 4. Right, now notice, ladies and gents, now what about the inverse? It would be exactly like the original graph. The only difference in this case is that now, remember we said it is actually on the negative y values, right? So what would be a point that I know of? All I do is just to swap around, okay, one of my points. So when x is 1 over 4, y is negative 1. As simple as that, ladies and gents. And remember that it is reflected by that line, y is equal to x. So that should be the reflection of our graph. Okay, right. And then finally, they want us to, oh, by the way, please remember to always label your x's, ladies and gents. So this would be y and x. Please, you lose marks if you do not label those x's, right? And they say, is the inverse of f a function? Give a reason for your answer. And the answer is a resounding yes. Okay? And why is that? Now, what helped is that they restricted this graph. So for every x value, for every one x value, there is one y value, or you can say it passes the vertical line test. Okay, so it passes the vertical line test, meaning when I pass it through a vertical line, there's only one y value for every one value of x. And essentially, that is how the cookie crumbles, ladies and gents. Right, so we go into question 7. Right, they say to us, we've got Diane who invests a lump sum of 5,000 in a savings account for exactly 2 years. The investment earns an interest of 10% per annum, compounded quarterly. Right, so the first question is, what is the quarterly interest rate that for Diane's investment? So remember, she invests at an interest rate of that's 10%, right, per annum. So now we want to make that a quarterly interest rate. So for 7.1.1, we know that our interest rate is simply going to be 10% divided by 4, and so that will be 2.5%. That's the interest rate, that's the quarterly interest rate, right? So they say calculate the amount in Diane's savings account at the end of 2 years. So remember that she took a lump sum of 5,000, right? So what she will do is that we want to know what will be the future value of that 5,000. So we're going to say A is equal to P. So we're using our compound interest formula. Right, so our principal amount is 5,000. That's 1 plus. Now remember, we've got 10%, right? So that's 10 over 100, which is 0.1. But remember, this is quarterly, okay? And we say this is after 2 years. So this would be 2 multiplied by the number of quarters in each year. Right, so let's find out what the accumulated amount will be. Okay, so we've got 5,000 into 1 plus, so that will be 0.1 over 4. Okay, and that gives us yx 2 times 4, and there we have it. So which means that that amount would accumulate to 6,092 rands, well, and 1 cent, if you want to be pedantic. Okay, so that is the amount that it will accumulate to, right? Okay, so and next question, they say Motloi inherits 800,000. He invests all of it in an of his inheritance rather, in a fund which earns interest at a rate of 14% per annum, compounded monthly, right? At the end of each month, he withdraws 10,000 rands from the fund. His first withdrawal is exactly 1 month after the initial investment, right? So in this case here we're going to deposit an amount of 800,000 rands. Okay, so it's that lump sum that we are going to put in, and they say that he will now make withdrawals, right? So that means that if this is our timeline, this is when he makes the deposit, 800,000. Okay, and they say exactly 1 month after the time, right? Then he starts making withdrawals of 10,000 rands. Okay, so what happens in that case? So they want to find out rather, how many withdrawals of 10,000 will Mutloyi be able to make from his fund. Okay, so we need to find out the number of withdrawals that he can make. Now remember, he makes those withdrawals on a monthly basis, right? So now there's actually 2 ways in which we can do this. I'm going to tell you the second one. So we can actually use our present value formula, right? And say, look, we know that the present value would be 800,000, and we are withdrawing an amount of 10,000 rands, and we want to know how many 10,000 rands can we actually withdraw, right? So we can say, all right, so this is x into, okay, present value formula, that's 1 plus I, okay, to the exponent minus n divided by I. Right, our present value is 800,000. Okay, we're withdrawing 10,000 rands. Okay, and this is 1 plus. Now we need to keep in mind, so our interest, we said that was 0.14, or at least it's given as 14%. Okay, but remember this would be monthly. So at the end of the day, we're going to divide this by 12, okay? And in this case, I'm going to say minus n, and put this n as the number of withdrawals, right? Because in this case, I'm not going to put it as the number of years, but as the number of months, okay? Which is a reflection of the number of withdrawals. So that's 0.14 divided by 12. Okay, so we're going to do some mathematical gymnastics over here, right? So we're going to cross multiply that, okay, and divide by 10,000. Okay, so I'm going to say, right, let's take that 800,000. Okay, right, so multiplied by 0.14 over 12. Okay, and we get that amount, and we divide that by 10,000. So divide that by 10,000 rands. Okay, so I get 0.93333. Okay, so 0.933 ... Okay, and in this case that will give me that entire bracket, which is 1 plus, okay, that's 1, okay, even if I take it out of that bigger bracket, 0.14 over 12 minus n. Now if I take the 1 to the other side, that becomes negative, okay, and in this case all right, what do we get? 0.99, and I will say minus the 1. Okay, and I get that entire value there, negative 0.066. Now, ladies and gents, please remember, I'm not going to remove that number there. Okay, so 0.067, but I am not going to remove the number 1 plus 0.14 over 12 minus n. Now, what do I do here? Right, this is where I am now going to introduce logs, right? So I am going to say, right, so if I take that, okay, so this would be the introduction of logarithms. Okay, so that would be the log of that number there. Okay, 0.67. Okay, which is minus n, the log of this entire expression, okay, over 12. And in this case, let's try and get that. Okay, right, so I'm going to say take the log of that answer. Okay, so the log of our answer, right, and I'm going to divide by the log of 1 plus 0.14 over 12. Okay, and there's my final answer coming up just now. All right, I get n, right, I get minus 233.47, okay, which is equal to minus n. So which means the number of the payments that he would be able to get would be 233, approximately 233 payments. Okay, or rather withdrawals, not payments, but withdrawals. Okay, there we go. All right, so that is how we'll get that number of withdrawals. Now remember, another way that you could have actually taken this is to actually say the accumulated amount from 800,000 minus the future value of all of these 10,000 rands that you are taking. Remember, the maximum amount would be when the accumulated amount would actually become 0, right? So as he withdraws, right, in this case, this amount, when the two are equal, then it means that the amount or the funds would have actually run out, and in that case you'd still be able to get exactly the same value. Okay, so let's go on to the next one. Right, now they say to us exactly 4 years after his initial investment, right, Mutloi decides to withdraw all the remaining money in his account and to use it as a deposit towards a house. Okay, now they say what is the value of Mutloi's deposit to the nearest rand? So I'm not sure how many months, how many years 233 withdrawals would be. You can just simply divide that by 12 to get the number of years, right? But now Mutloi does not wait till to get to those number of years, but instead what he's going to do is just make a withdrawal, take a lump sum, right, and use it as a deposit to the house. In this case, that is after 4 years, right? So now, which means we are looking at finding the balance of this loan. So we're looking at the balance of, not the loan, rather, the investment. How much is still left after he's made withdrawals for 4 years, right? So I'm going to use exactly this method, but this time our balance is not going to be 0. Okay, so we're going to look for now the balance, right? So I'm simply going to say, right, it's going to be the accumulated amount, right, minus the future value of all the withdrawals that he keeps making, and that would give me the balance on this particular amount, right? So in this case, they said to the nearest rand, okay? So we're not going to worry ourselves about the cents, right? So now, what are we going to do? We're going to say, right, so this is 800,000 rands, okay, into, okay, maybe let me just write down the formula. So that's going to be the principal amount, and 1 plus I to the exponent n minus x. So these are the withdrawals that it keeps making. Future value, that's 1 plus I, exponent n minus 1 divided by my value for I. Right, so let's put those values. So that's 800,000 into 1 plus 0.14 over 12, right? And in this case, this is after 4 years, right? So please remember 4 years monthly, that's 12 times 4, okay, which is 48. Okay, and so that would be 48 months minus that 10,000. Okay, this is into 1 plus 0.14 over 12 times 48 minus 1 divided by 0.14 over 12. Okay, so let's look for that balance now. Okay, so we're going to say this is 800,000, okay, into 1 plus, okay, 0.14 over 12, and this would be yx 48. All right, now this is subtract, and please note I'm gonna do all of this in my calculator, right? So let's do this. So I'm going to do the following. Okay, so let's open that bracket there. Okay, so this is over 12. Right, now these can be very tedious, ladies and gents, and please make it a point that you do as much as possible in your calculator. Okay, so that's minus 1. That's minus 1, and let's close that bracket, and this would be divided by 0.14 over 12. Okay, so there it is. What would be the balance? That would be 757,420. Okay, I'm going to say 428,000. Okay, that's to the nearest rand. Okay, so that would be the amount, in this case, the deposit that he will use. Okay, right, so finally they say Mutloi's deposit is 30%, is exactly 30% of the purchase price of the house. What is the purchase price of the house to the nearest rand? Okay, so how do we get that? So we're going to simply say, right, so remember 30% of the purchase price, okay, will be equal to 757,428. Okay, so remember, what is 30%? That's 30 over 100, which is 0.3, okay, multiplied by the purchase price. So to get the purchase price, I will divide by 0.3 on either side. So what would be my purchase price? Take that amount there, okay, and I will divide it by 0.3. And what I get there is 2,524,700 and let's say 761. Okay, right, and so that is how we will get the purchase price of the actual property that he wants to purchase. All right, so that is how the cookie crumbles. I hope that you got it in terms of finance. Right, let's move on to the next question. And moving on to question 8, so we say determine f prime x from first principles if f of x is minus x squared plus 4. Right, let's try and do that as quickly as we possibly can. So we know that if we take f prime x, first of all, let's start with given the f of x, which is x squared plus 4, right? Okay, minus x squared plus 4. Okay, so we know that if we take f of x plus h, what will this be? This will be minus x plus h squared plus 4. So we can actually just try to simplify this. That would be negative. That's x squared minus 2xh, actually plus 2xh plus h squared, okay, plus 4. And let us try and multiply that. So minus x squared minus 2xh minus h squared, okay, plus 4. So this is f of x plus h, right? So when we take first principles, so in this case, f prime x is equal to limit as h tends to 0, f of x plus h minus f of x divided by h, right? So limit as h tends to 0. Please don't drop this until you substitute by h. F of x plus h, we've now found out this is minus x squared minus 2xh minus h squared plus 4 minus, remember f of x was minus x squared plus 4 divided by our h value. Okay, so this again is limit as h tends to 0. Right, so you notice here we're going to have, if we multiply by that negative, okay, if you don't mind, I'm just not going to have another step here. This is going to be plus and minus, isn't it? So what happens? That x squared cancels with the minus x squared, that's that negative 4 with the positive 4, right? So I'm left with minus 2xh, right? So let's take h out as a common factor. I'm left with minus 2x, right, minus h divided by h. So that and that cancel. So in this case, I'm now going to put h minus 2x plus 0, and that means f prime x will actually be equal to negative 2x. Okay, right, so that makes sense. Okay, let's go on to the next one. They say determine the derivatives of the following, right? So 8.2.1, we've got 3x squared plus 10x. Okay, so 8.2.1, y is equal to 3x squared plus 10x. So remember, so you first get rid of anything that may, your brackets, you get rid of any value of exponent that is negative, okay, or any surds for that matter. So in this case, we are okay. So dy dx, right? This will be 6x plus 10. Okay, and the next one, 8.2.2. So we are given, so that's 3x squared plus 10x. Okay, so the next one, they're giving us there f of x, which is x minus 3 over x all squared. Okay, so that's f of x, which is x minus 3 over x all squared. Okay, am I correct? Okay, so there we are. So what do? We get rid of the bracket in this case, so we're going to expand. Okay, so this will be x squared, right? X times x. So x multiplied by negative 3 over x, that will give us minus 3 times 2, that will give us minus 6. Okay, plus this will be 9 over x squared. Now let's try and simplify so that we don't have any x's or variables at the denominator. So this will be minus 6 plus 9x minus 2. So that's f of x, right? So f prime x, that would be 2x minus 18x minus 3. Remember, we use our jump down rule, so 2 times negative 2 times 9 is 18, but we say minus 1 to the exponent, that's minus 3. So if you want to, so this would be minus 18 over x cubed. Okay, so that is our f prime x. Okay, right, let's go to the next question. So now we go into the cubic function, right? So they say to us, we've got f of x, right, which is given to us as 2x cubed, right? So we've got that value 2x cubed minus 23x squared plus 80x minus 84. They say prove that x minus 2 is a factor of f. Right, no, so 8.3.1. Now f of x is equal to, we said this is 2x cubed minus 23x squared plus 80x minus 84. Now, ladies and gents, I want you to note, how do I prove that it is a factor? X minus 2 is a factor. I simply multiply, or rather substitute 2, right? Remember, if x minus 2 is a factor, that means x minus 2 is equal to 0. And in this case, that means x is equal to 2. So we substitute a positive 2 there. So we should get a 0. So that's 2 cubed minus 23 times 2 squared plus 80 times 2 minus 84. And let's check, does it actually give us, so that would be 2 cubed, okay, that's minus 23 times 2 squared plus 80 times 2 minus 84. And what does it give us? gives us 0. Therefore, it means x minus 2 is a factor. So they've made the work easier for us by finding the factor, so we'll be able to factorize much easier. So they say to us, hence or otherwise factorize f of x fully, right? So let's try and factorize. Okay, so 8.3.2. So that means that we've got x minus 2 into, now notice ladies and gents, x multiplied by what will give us 2x cubed? That will be 2x squared. Let's go to the last term. Negative 2 times what will give me negative 84? That will be positive 42. Okay, right. And now I always say let's take the plus bx, and this would be equal to 0. So what is our x squared term in this case? So that would be negative 2 times 2x squared. That will be minus 4x squared. Okay, some of you prefer to use a different method here. Use whatever it is that is comfortable to you. Plus bx squared. Okay, and in this case, remember when I add these two up, it must give me that and minus 23x squared, right? So that's minus 23x squared. Now we can drop the x squareds, right? So that means that minus 4 plus b would be equal to minus 23. And so b would be equal to minus 23 plus 4, which would give me negative 19. So that means that we've got x minus 2 into 2x squared minus 19x plus 42, and this would be equal to 0, right? And remember they said we must factorize fully in this case. So are we able to factorize that? So factors of 2, okay, that's 2 over 1, factors of 42, such that when I add them, give me 19. Okay, so I am going to take, so that's 7, and so that's 21. 7 times 3 is 21, so that would be 7 times 6, right? So let's check. 2 times 6 gives me 12. 7 times 1 gives me 7. And so that means that's my first bracket and that's my second bracket. So that would be x minus 2. The other bracket is 2x minus 7. And the other bracket is x minus 6. All right, and this would be equal to 0. Right, so the next question says determine the coordinates of the turning points of f. Now remember, how do we get the turning point? Right, we take the derivative and make it equal to 0, right, to get the x value of the turning point. So 8.3.3, we're going to say, well, take f prime of x, make it equal to 0. And what is f prime going to give us? Remember, we had 2x cubed, so that will be 2x cubed. That gives us 6x squared minus 46x plus 80. This is equal to 0. Okay, so can we actually divide by 6? No, I don't think so. But we can divide by 2. This would give us 3x squared minus 23x plus 40. Okay, and this would give us 0. Right, so let's see once again. So we've got factors of 3, that's 3 and 1. Factors of 40, such that when I multiply and add, let's see. So if we took 8 times 5, okay, all right, so 8 times 5, that's 40. So 3 times 5 is 15. Okay, 15 plus 8. Oh, I keep getting luckier and luckier, right? So in this case, this would be 3x minus 8. And the other one is x minus 5 equal to 0. So that means that my turning points are 8 over 3 or x is equal to 5. Right, now did they say the coordinates? Let's check. Oh, they said determine the x coordinates of the turning point. So I don't need to actually continue to find the y coordinates, right? Now they say sketch the graph of f, clearly labeling all turning points and intercepts with the axes. All right, so what is our graph going to look like? So first of all, our a value is positive. So it tells us it starts as an increasing function. Okay. So there we go. Right, so don't forget to label your axes. So that's x and that is y. So I know at 8 over 3, okay, so 8 over 3, I've got a turning point. Now because I know that I started in this case with an increasing function, it means first I'm going to have a maximum point. All right, and then I'll also have at x is equal to 5, our minimum point there. Now I know my graph cuts at 2, at 7 over 2, as well as at 6. Okay, so at 2, at 7 over 2, okay, as well as at 6. Okay, so, and our y-intercept in this case, y-intercept would be at negative 84. Okay, so that would be negative 84 there. All right, so this is what our graph would look like. That's our turning point. All right, so that is what our graph would look like. Okay, right, so this is our first turning point. And the value, we said that was 8 over 3. Yeah, so that's 8 over 3. And some y value of the turning point. And then this value here would be 5. And some value of the turning point. Now please notice, ladies and gents, we also have our x-intercepts. Said the first one is at 2. And the others at 7 over 2. And the last one, which was at 6, right? So this is a 6. All right, so that is what our graph will look like. Okay, and please make it a point that you get this one right. Finally, they say determine the coordinates of the y-intercept of the tangent of f that has a slope of 40 and touches f at a point where the x-coordinate is an integer. So we want where the gradient of the graph is 40 and that value must be an integer. Right, so let's do that. Okay, so how do we get the derivative? Remember we said we take f prime. We've already found that in this case that's 6x squared minus 46x plus 80. Okay, and now because we're dealing with f prime in this case, want to know where is our derivative equal to 40, which is the gradient. So let's say 6x squared minus 46x, right? If I take the 40 to the side, that would be plus 40, and this is equal to 0. Okay, right, and in this case again we're going to divide by 2. X, so that will be 3x squared minus 23x plus, okay, divide by 2, that will give us 20. This is equal to 0. So that gives us 3 over 1, and that would be 20 over 1. If I cross multiply, 3 times 1 gives me 3, 20 times 1 gives me 20. And if I add those up, they do give me 23, right? So that will be my first bracket, and that would be my second. So that will be 3x minus 20, and the other one is x minus 1. And this would be equal to 0. Now, note in this case, x is 20 over 3, or x is equal to 1. Now, note they did say to us that it must be an integer, right? Okay, the x-coordinate is an integer, so which means in this case we're going to take x is equal to 1. And we want the y-intercept, so which means, okay, the tangent rather is equal to, or rather the gradient of the tangent is 40 at x is equal to 1. Okay, so now that means that y is equal to 40x plus c. Now where are we going to get our c value? Right, so we're going to need to get f of 1. Okay, so I'm substituting that value, so this one is not applicable, right? F of 1 into the original equation so that I get the corresponding y value. Okay, and remember in this case we've got 2 times 1 cubed minus 23 times 1, okay, plus 80 times 1 minus 84. Okay, so let's get that quickly. So that would be 2 minus 23 plus 80 minus 84. Right, so that gives us negative 25. All right, so we know when x is 1, y is negative 25. So that would be minus 25 is equal to 40 times 1 plus c. And if I take that to the other side, 40 times 1 is 40. Take it to the other side, that gives us minus 65. So y would be equal to 40x minus 65. Okay, so this is where the gradient is actually equal to 40. That's the equation. But in this case, is that what they were looking for? They said the y-intercept. Actually, the y-intercept is just simply the value that we got there, which is 65. Okay, right, minus 65. Ladies and gents, that brings us to the end of that question. All right, we'll look at the next one in just a few. And so we begin with question 9. All right, so let's go. They say a soft can has a volume of 340 cubic centimeters, a height of h centimeters, and a radius of r centimeters. And they want us to express h in terms of r. Now, the clue here is always to try and use what's already given, and what's already given is the volume, right? And how do we get the volume? In this case of this can, right? Remember that it's the area of the base. So if you think about what a can looks like, right? You've got a circular base, right? And in this case, multiplied by its height, okay? Right. Hope my can is not that bad. Okay, so of course, here's our base, which is a circle, right? Multiplied by the height, and that will give us the volume. So we're going to say, so the volume would be the area of the base, which is a circle, pi r squared, multiplied by the height. So this would be h, okay? And they want us to express h in terms of r. So the volume is given as 340. Okay, so this is pi r squared h, and of course, to make h the subject of the formula, so we're going to just simply divide by pi r squared. That cancels with that, and so what we have is h is 340. Okay, so that's 340 divided by pi r squared. All right, so that is the expression of h in terms of r. Now they say show that the surface area of a can is given by, okay, so that's the entire surface area. Now remember, when we talk about the surface area, first of all, okay, so if our can is closed on both sides, okay, so we know we've got these two circles here at the bottom and at the top, and then we've got the surface area of, you know, the can all around, right? The surface area around the can. And so in this case, what are we going to have? So we know that we're going to have, right? So the surface area, so that's 9.2. Okay, they said it's a in terms of r, right? Would be 2 times pi r squared, okay, the two circles at the bottom and at the top, plus, right, remember this is 2 pi r, so it would be the circumference of the circle multiplied by the height. So this would be 2 pi r multiplied by the height h. But now what we want is that we don't want any other variable, we want just r. So we're going to have 2 pi r squared plus 2 pi r, and you remember that h is 340 divided by pi r squared, okay? So we're going to have 2 pi r squared plus, now notice this pi will cancel that pi. One of the r's at the top will cancel one of the r's at the bottom. So we end up with 2 times 340. This would be 680, right? Divided by r, okay? So that would be r minus 1. Okay, so that is what we get as our surface area. All right, and that's exactly what we have there. So they said determine the radius of the can that will ensure that the surface area is a minimum. So every time that we are supposed to get or to minimize something, right? So we're trying to minimize the surface area. So what do? We take the derivative and we make it equal to 0. So which means a dash of r must be equal to 0, right? So we are deriving with respect to r, right? So which means it's what's on r that jumps down. So this is 2 times 2, which will give us 4 pi. Now remember minus 1 of the 2 there. Okay, so in fact, let me just write AR so that for the sake of those who want to understand what I'm doing. And this is 680 R minus 1. So we said this is jumping down. So that gives us 4 pi R. Okay, remember jump down and minus 1. And then that minus 1 jumps down. So 680 times negative 1. Okay, so that's minus 680, right? And minus 1 there. So that becomes R minus 2. And this would be equal to 0. Right, now, what are we left with? We've got 4 pi R. Okay, so 4 pi R equal to, now remember this is 680 on the other side, once I take it to the other side, divided by R squared, right? Okay, so we can cross multiply here and say, well, if we cross multiply, we've got 4 pi R cubed, which is equal to 680. And we can divide both sides by 4 pi. And if we do that, we get the value of R to be the cube root of 680 divided by 4 pi. Okay, and let's see, what do we get there? So if we say the cube root of 680 divided by 4 pi. All right, so I get 3.78. Okay. Right, and remember this was in centimeters, so I'm going to give that answer in centimeters. Okay. Right, and that would be the value of R. And ladies and gents, that is what we do when we are optimizing. Just take the derivative, make it equal to 0. All right, and that is where we leave this question as we do the last question. And finally, question 10, ladies and gents. Right, so we are looking at probability, your favorite section. All right, so let's start with the first one. They're giving us a contingency table there. Okay, so let's take this one down a bit. Okay, so they say each passenger on a certain Banana Airways flight, choose exactly one beverage from tea, coffee, or juice. The results are shown in the table below. All right, so they say to us, write down the value of A. Now, you'd notice that when we've got a contingency table, whatever this value is, okay, so whatever this value is, you either sum it going down, okay, so we can take the sum of it going down like this, or we can take the sum of it going across like that, okay. So either way we get the same value. So we can say 60 plus 80 plus 20, right, which will give us 160. Or I can say 100 plus 60, which will give us 160. So the value of A should be 160. Okay, so I hope that makes sense. And they ask us, what is the probability that a randomly selected passenger is male? Okay, so remember our total sample space is 160. And in this case, what would be the total number of males that we have? That's 60, right? So the probability of being a male or of finding a passenger being a male, we would say the probability of finding a male would simply be 60 divided by 160. Okay, so I'm going to just leave it like that. If you want to, you can actually find, okay, let's just write it there. So that's 0.375. Okay, right, so the last question there before we go to the other section of the banana airways. They say when that event, or rather, given that the event of a passenger choosing coffee is independent, okay, of being a male, calculate the value of B. Now remember, what happens with independent events, ladies and gents, right? So remember, when we've got an independent event, the probability of A and B would be equal to the probability of A multiplied by the probability of B, right? If this holds, then it means that those events are independent, right? So now we are looking at being male and choosing coffee. So the probability of being male, so this would be male and coffee, okay, should be equal to the probability of being male multiplied by the probability of coffee. Okay, right, so let's see, where are all the males that choose coffee? Okay, so that would be B, so male choosing coffee, that would be B over 160, right? And then, so that's male and coffee, right? So that's B over 160. Okay, and this would be equal to, now note the probability of being male, we just calculated it now. That was 60 over 160 multiplied by the probability of drinking coffee. So the total number of people that take coffee, in this case, that would be 80, right? And that would be divided by 160. So that's 80 over 160. All right, so we're going to do some gymnastics there mathematically. So if we say we've got 60, so that's 60 over 160 multiplied by 80 over 160. Okay, I get 3 over 16 on this side, and this would be B over 160. All right, so to get the value of B, all I need to do, I'll multiply by 160 on this side and multiply by 160 on the other side. So that cancels with that. And so the value of B is 3 over 16, okay, multiplied by 160. And I get the value of B to be equal to 30. All right, so please remember, for independent events, right, this is the statement that you will always use. All right, so let's go to the last part of the question. They say a banana aeroplane, a Banana Airways aeroplane has 6 seats in a row, right? I always like to actually draw my scenario, right? So we've got 6 seats in a row, okay? I always find counting principles to be much better when you try to draw your scenario, right? Okay, so we've got 6 seats in a row, and they say how many possible arrangements are there for 6 people to sit in a row of 6 seats. Now remember, you've got 6 people and you've got 6 seats, right? So remember, in your first seat, how many people, what's the number of people that you have available? You've got all 6 of them that you can place there, right? But now that you've placed 1, how many do you have available? You've got 5 to choose from. And now that you've placed the 2, right, how many do you have? 4. And of course, you can see how that progression goes. So that means that in this case, all you simply do is to multiply that there. So that means for 10.2.1, you can actually seat them in 6 factorial ways. Okay, so if you want to, we can take 6 factorial. This is 720. Okay, right. Now, they say Xoliswa, Anis, and 4 other passengers sit in a certain row, right, on a Banana Airways flight. In how many different ways can these 6 passengers be seated if Xoliswa and Anis must sit next to each other? Okay, right. Now, Xoliswa and Anis want to sit next to each other. So what happens? So I'm going to take them as just simply one item, right? So remember, what happens this time around? It means I need to get 5, because they are sitting next to each other, 5 of them seated, right? Because they are seen as one item. They have to sit next to each other, right? And it doesn't matter where we place them, right? So in this case, I want you to please note, that means now I have 5 different arrangements, right? So of course, so in this case, I've got 5 factorial, right? I've got, of course, I can sit 4, I can sit 3, I can sit 2, right? Now, please, I want you to note, ladies and gents, now, when it comes to Anis and Xoliswa, so the thing about it is that I can put them in one of 2 ways. Either I can start with Xoliswa and then Anis, or I can put Anis, then Xoliswa, right? So there are 2 different arrangements that I can make for them, right? So yes, there's one way in this case because they have to sit together, but in this case, within themselves, they can actually sit in 2 different ways. So that means that if I now take this, it will be 5 factorial ways, but I would multiply this by 2 because there are 2 different ways of sitting them. Okay, so let's take that. So that's 5 factorial. Okay, and multiply that by 2, and I get 240 different combinations there. Okay, so that is how we will do that. So let's look at the last question. They say Mary and 5 other passengers are to be seated in a certain row, right? If seats are allocated at random, what is the probability? Now note, we are now not looking for the number of ways, we're looking for the probability that Mary will sit at the end of the row. Now, ladies and gents, please remember, so the end of each row or the end of a row comes in 2 ways, right? It could either be the end from the left-hand side, okay, or it could be the end on the right-hand side. Now, let's assume that she will sit on the edge on the left-hand side. So this would be Mary over here, right? So once we get Mary seated, remember we just want her at the edge, right? So in this case, how many different ways can I seat the others? Okay, now I've got 5 to choose from, right? And 4 to choose from, 3 to choose from, 2 to choose from, and 1 to choose from, right? So in this case, with the first one, it's Mary on the left-hand side and 5 others seated at in any particular order. So this would be 5 factorial multiplied by 1 because that's where I seated Mary. But please remember that I can also sit Mary at the end. So if I place Mary on the right hand side, so if that's Mary over there, right? So I place her there, so I can only place her in one particular way, right? So in this case, in my first seat, again, what can I do? I've got 5 to choose from, got 4, I've got 3, I've got 2, and I've got 1. So I'm going to add that permutation now, in this case, so sitting Mary on the right hand side. So this was sitting here on the left, this one is sitting here on the right. So that would be 5 factorial again, multiplied by 1. Okay, now remember they were asking about the probability of sitting here at the edge, right? So the probability that Mary will be at the edge will be this total number of permutations, either sitting here on the left or on the right. So it would be 5 factorial plus another 5 factorial. Okay, this is divided by the total number that we had in this case of ways in which we can sit them, and that's 6 factorial, right? So let's find that out. So that would be, okay, 5 factorial. So that would be 5 factorial plus 5 factorial. Okay, and this would be divided by 6 factorial. Okay, so in this case, it means the probability that she will sit at the edge will be 0.33, or you can simply say that's 1/3. Okay, right, and essentially, ladies and gents, that is how the cookie crumbles. I hope that you guys enjoyed this question paper. Of course, we'll come back for more as you guys prepare for your exams. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.